All right, we're looking at composition of functions. What that means is we're applying one function to the results of another. In other words, we're plugging one function into another one. All right, these are some notations you're going to see. That f, that circle, and then g of x, or f of g of x is what it's read as. Same deal with that g and f on the second one. It's read as g of f of x. So what that looks like is I'm going to give you two functions. In this case, I got 5x plus 4 is the f function. The g function is 4 minus x. The notation, both of those are fair game to see. All right. I personally prefer to look at the second one. So I typically rewrite it into the second one. That's why you see me write it here below. I'm going to use the colors. Hopefully that kind of helps out in the beginning here. So the first thing we're going to do is we're going to find f of g of x. So what that means is I'm going to take my g function, I'm going to replace that. So instead of saying f of g of x has a value. It's 4 minus x. We've had practice plugging this stuff into our functions. I'm going to take 4 minus x and plug it in for x in the f function. So I have 5 times 4 minus x instead of x plus 4. You do whatever algebra you need to do. In this case, we need to distribute. We get 20 minus 5x plus 4. We don't distribute to that 4. We continue on, combine like terms. 20 and 4 get combined. I get negative 5x plus 24. And that's what f of g of x is equivalent to. I'm going to do the same thing in the second one. I'm just going to plug in the f function into the g. So I go g of 5x plus 4 instead of f of x. What that looks like is this. I go 4 minus parentheses 5x plus 4. Again, do whatever arithmetic you need to do. I need to distribute a negative in this case. Get 4 minus 5x minus 4. Combine like terms. The 4's actually cancel out, and all I am left with is negative 5x. And that's what g of f of x is equivalent to. Plugging one function into another. Second example here, same thing, two different functions. This looks much worse than it really is. So I called them something different. It's g and h this time. So just look at the notation, see what you got. I'm going to have g of h of x. I'm going to go g of x squared minus 6. Plug that in. So I plug in that function. I go square root of x squared minus 6 plus 6 inside there. All I need to do is combine like terms. Those cancel out. I'm left with the square root of x squared, which is just x. That's what g of h of x is. Just x. Similar, I'm going to go h of g of x, so square root of x plus 6 is what I'm going to plug in. So I go square root of x plus 6 squared minus 6. Remember your rules with radicals. You square a square root. That just cancels out the square root. So you're left with x plus 6 minus 6. 6's cancel again, and we're left with x again. All right, it's just a matter of what we have. That's not always something that happens. There's our answer for each of those. Now, we could also be plugging in numbers. I have another example here typed out. You can take a look at it later on. But we can also plug in numbers. Let's check this out. I have 3 functions, so you just got to look at the notation. The first thing I ask you to find is g of f of 3. Again, I prefer this notation. So what you need to do first is find f of 3 first. F of 3 is 9 minus 3, which is 6. So if f of 3 is 6, so I'm going to rewrite this. So g of f of 3, we know f of 3 is 6, so we're really finding g of 6. G of 6, same deal. Just take that 6, plug it in to the function you need to in for x, and take it from there. We get 36 plus 6, which is 42. That's your final answer. Moving on, same thing. H of g of 3, we're plugging in the same value, different functions though. We find g of 3 first. G of 3 is 3 squared plus 3, which is 9 plus 3, which is 12. That is g of 3. We take that g of 3, since we're finding h of g of 3, so we're really finding h of 12. So we take that 12, plug it into the h value. So h of 12 is 12 minus 2, which is 10. And there's our final answer that we're looking for. Not both, whatever you end up with it at the end. Same functions, last 2 here, some different twists that we could see. F of negative 8. So what this is saying is I'm going to plug negative 8 into the f function, and whatever answer I get there, I'm going to take that, I'm going to plug it into the f function again. So f of negative 8 first. Let's see what I get. I get 9 minus negative 8 turns into 9 plus 8, which is 17. That's what f of negative 8 is. Moving forward, I take that value, I plug it into the f function again. Is f of negative 8 is really saying I need to find f of 17. F of 17 then is 9 minus 17, which is negative 8. You're not always going to get the same answer that you started with, but that's something odd that we see, and that's just fine. So we get negative 8. Now, last one, biggest one. We're plugging values into all 3 functions. Start with the innermost, h of 4. H of 4 is just 4 minus 2, which is just 2. Then we need to find f of h of 4. F of h of 4 is really saying f of 2. Well, f of 2 is equal to 9 minus 2, which is 7. Lastly, we need to find g of f of h of 4, which is really saying all of this ended up being 7. We need to find g of 7. G of 7 is 7 squared plus 7. 7 squared is 49 plus 7. We get a 56, and that is your final answer. We had to go through all 3 functions to find our final solution here. Once again, I have some typed up examples if you need some extra examples, that I'll put in the notes in the end. So make sure you take a look at them, please.